We've already thought a little bit about various ways that you can speed up multiplication. We've seen quarter squares, log tables, and even slide rules. There's another method that was super popular in the quarter century before Napier unveiled logarithms to the world. The method has the admittedly very pretentious name of prostaphoresis. The idea is to use a cosine product identity. Namely, this formula, the cosine of A times the cosine of B, is the cosine of A plus B and the cosine of A minus B averaged together. Perhaps somewhat surprisingly, you can use this cosine product identity to multiply numbers. Let's see how. So let's try to use this trick to multiply 0.17 and 0.37. Now, these numbers are so small you just multiply them out, but it'll demonstrate the trick that would work on more complicated looking numbers. The formula that we're trying to use is this cosine A times cosine B formula. I can only multiply together cosines, so I should rewrite 0.17 and 0.37 as cosine A and cosine B. Now if I look at my table of inverse cosine and I look up 0.17, I find that cosine of 1.39997 is close to 0.17. I can also use my table to compute arc cosine of 0.37 to be about 1.19179. In other words, if I take cosine of this number, I get really close to 0.37. Now the formula that we're trying to use is this formula that tells me to compute A plus B and A minus B. So given that I've got these approximate values for A, I can compute A plus B to be 2.59176 and A minus B to be 0.20818. Here I've got a table of cosine values, and if I look at 0.20, the 0th column, 1st, 2nd, 3rd, 4th, 5th, 6th, 7th, 8th column, I find out that cosine of 0.208 is about 0.97845. And I can similarly use my table for cosine to approximate cosine of A plus B. It's negative 0.85261. Now the formula that we've got for the product of cosine A and cosine B tells us it's the average of cosine A plus B and cosine A minus B. I've computed cosine of A minus B and cosine A plus B, so all I have to do is take the average of these two numbers, and if I average these two numbers I get 0.06292. Wow! I mean, look, this average is really close to the actual product of 0.17 and 0.37, which is 0.0629. We're managing to multiply together numbers by rewriting those numbers as cosines and using this formula that tells me how to multiply cosines. Instead of actually multiplying, I've replaced the multiplication with additions, differences, table lookups, and an average. Logarithms were obviously a huge improvement over this method, but it's pretty fantastic to think that 400 years ago, humans were trying to figure out how they could use trigonometric identities to do things like multiply numbers. That required a tremendous amount of creativity to think that the things about triangles would have anything to do with multiplying numbers. In other words, trigonometry is not just about triangles. You can do more than just understand triangles if you really understand a whole bunch of trigonometry.